So when we're adding fractions or subtracting fractions, we need to have the same denominator. That's because if I try to say something like 5 cats add 2 dogs and I get 7 somethings, I won't know what something to say. I couldn't say it was 7 cats, or I couldn't say it was 7 dogs, because they're different things. It doesn't make sense. Or, 1 apple plus 2 oranges doesn't equal 3 apples. So I need to make sure the denominator is the same, because saying something like 3/6 add 1/3, I need to make the denominators the same before I do that in order that it will make sense. If that wasn't clear, hopefully when I start doing this, it will make a bit more sense. Now, on my comparing fractions videos, I did look at how to find the same denominator. So those are other ones you can have a look at. And I'll put the links in the description. But for now, let's just have a quick recap of how we could do it. So we could make the denominators the same using a picture like this. So if I'm looking at something like this, my first picture is showing me sixths. This bar at the top, this bar model here, is cut into 6 pieces. And if I colour in 3 of those, I've coloured in 3/6. Now underneath, directly the same size, matching up, I could colour in 1/3. That's all very well. It's not actually helping me at the moment to see my answer. What I need to think about is what would 1/3 be the same as in sixths. Now, if you look carefully at this, you might see that if I did a little line down there, that my sixths are the same size as two of my sixths are the same size as 1 of my thirds. So I would keep my 3/6 the same, but my 1/3 now, instead of just being 1/3, is actually going to become 2/6, because that's what I can see from this picture, that 1/3 is the same as 2 of those. So now if I ignore my starting question and look at this bit, I've got something that I can do because the denominators are the same. 3/6 add 2/6 equals 5/6. So if you didn't want to use a picture, you can do it just using calculation. And again, more detail is on my other videos. So if I look at this one and I'm thinking, right, I've got a quarter and I've got 3/8. I need the denominator to be the same. My first question is always, could the smaller denominator go into the bigger one? And in this case, yes, 4 does go into 8. So my 3/8 is staying as 8ths, and I'm also going to make my quarters into 8ths. So if I am thinking to myself, how did my 4 become an 8? Well, what I've done is I've timesed it by 2. And as I said a lot of times in my other videos, if I'm timesing my denominator by 2 to get from 4 to 8, that's what I also do to the numerator. So 1 times 2 would be 2. So now I know 1/4 is the same as 2/8, and I can do my addition. 2/8 add 3/8 equals 5/8. But sometimes when you ask yourself that question about whether denominators go into each other, it won't be so clear. I could say to myself, does 3 go into 5? No. Does 5 go into 3? No. So I need to find something that they do both go into. So if I think about my times tables, I can think to myself, I know that 5 and 3 both go into 15. They go into other numbers as well, but 15 is a nice simple one. So I'm going to make the denominator 15 for both. Now, I need to think about what I've timesed by. So to get from 5 to 15, I'm timesing by, can you work it out? I'm timesing by 3. 5 times 3 is 15, which means that is what I also do to my numerator there. So 3 times 3 is 9. So 3/5 would be the same as 9/15. Over here, it will be a slightly different number because I've started with thirds. So to get from 3 to 15, I times by 5. And then, as always, I have to do the same to the numerator. So 1 times 5 is 5. So now what I've got, and make sure you're looking at the operation here, I'm doing subtraction this time, 9/15 take away 5/15 would give me 4/15. There we have it.